So you're building a web app, right? One of the first things you've got to figure out is how to manage your users. But how do you do it securely without having to reinvent the wheel every single time? Well, today we're going to pull back the curtain on Django's built-in authentication and authorization system. It's an absolutely killer toolkit that does all the heavy lifting for you. Let's dive in. Okay, first things first, we have to get two core ideas straight: authentication and authorization. Honestly, the best way to think about it is like a nightclub. Authentication, that's the bouncer at the front door checking your ID. He's just verifying who you are. Authorization, on the other hand, is the key card you get once you're inside. It decides what you can actually do. Like getting into that exclusive VIP room. One proves you're you, the other says where you can go. So where does Django even begin with all this? It all starts with a solid foundation, the user model. See, instead of forcing you to build a whole user system from scratch, which is a huge pain, Django just hands you a robust, ready-to-use model that does pretty much everything you need right out of the box. And when I say ready to use, I mean it. Django's default user model comes preloaded with all the essentials. You get the basics, of course, like username and email, but you also get these super useful little flags, like is staff and is super user, which, trust me, become absolutely crucial for controlling who can do what later on. And most importantly, it comes with a password field that is always stored securely. Creating a user is just beautifully simple. Look at this. A single line of code using the create user method is all it takes. But the real magic, that's happening behind the scenes. Django never saves RAM123 as plain text. Nope. It automatically scrambles it into a secure hash before it even thinks about touching the database. We'll get into exactly how that works in just a minute. All right, so we've got a place to store our users. Now, how do we actually manage the front door? Let's talk about the user lifecycle, getting people registered, logged in, and, just as important, logged out safely. The login process itself is a really simple three-step dance. Step 1, you grab the username and password from a form. Step 2, you authenticate those credentials against what you have in the database. And Step 3, if everything checks out, you log the user in by creating a secure session for them. It's a logical, safe, and clean flow. Now, that second step, authentication, it really all boils down to one single critical function: authenticate. You can think of this thing as the system's ultimate gatekeeper. You hand it a username and password, and it does the complex, secure check against the database for you. If they match, it gives you back the user object. If not, you get nothing. It's just a super clean and powerful design. And hey, on the flip side, getting a user out is just as easy. It's one function call, logout request, and that's it. Django takes care of tearing down the user's session, basically showing them the door until they decide to come back and log in again. Okay, this brings us to a really, really important topic: security. I mean, we've talked about creating users and logging them in, but how is Django actually keeping their sensitive info, especially their passwords, safe from prying eyes? Let's get into the vault. So let's just ask the questions straight up. We know it doesn't store them as plain text, because that would be a complete disaster from a security standpoint. So what is actually happening under the hood when a user signs up and gives you their password? And here's the answer. On the left, you've got the super insecure plain text password. But on the right, that's what Django actually stores. It's this long, complex string called a hash. Now, this is a one-way street. You can turn RAM123 into that hash, but you can never, ever go backwards. This is so important. It means that even if an attacker gets into your database, they won't find a single password they can actually use. And Django doesn't just use any old hashing method. By default, it uses an industry-standard, battle-tested algorithm called PBKDF2. The whole reason this one is chosen is because it's designed to be slow and to take up a lot of computing power. That makes it incredibly resistant to what are called brute force attacks, where hackers try to guess millions of passwords a second. So, once a user is logged in. All right, we've totally covered authentication, so now we know who the user is. It's time for that second key concept: authorization. Now we have to decide what that user is allowed to do. So, welcome to the VIP room. Django makes basic authorization ridiculously easy with something called a decorator. Just by adding @LoginRequired right on top of one of your view functions, you've instantly put a lock on that page. It's like a deadbolt. If someone who isn't logged in tries to go there, Django will just automatically kick them over to the login page. It's an incredibly powerful one-line security feature. But what if you need more control?
What if a page should only be seen by, say, staff members? For that, you can use the @user_passes_the_test decorator. All we're doing here is giving it a quick little test. Hey, for this user, is their isStaff flag set to true? If the answer is yes, they're in. If it's no, they're denied. It's that simple.
What all this shows is that Django gives you a complete authorization toolkit. For the simple stuff, you have these easy on-off flags like isStaff right on the user model. But for more complex apps, you can build out a full role-based access control system with groups and permissions, letting you define roles like admin or editor with really specific rights. So let's just pull it all together real quick. We have the user model to store the data. We have the registration and login flow to handle authentication. We have powerful password hashing to keep secrets safe. We use session management to remember who's logged in. And we have role-based access control for deciding who gets to do what. These are the core pillars of Django's entire security system.
And that brings us to one final thought. Now that you've seen the whole picture, really think about this. If you were in a technical interview and someone asked you how Django secures user passwords, what would you say? You wouldn't just say it hashes them. A great answer would be talking about the one-way nature of that hash, mentioning the specific PBKDF2 algorithm and explaining why that makes it so tough to crack. See? That's the difference between just knowing a fact and truly understanding a concept.